thank you for joining us. My name is Michelle D'Amico. I'm the Director of Continuing Education and Public Programs at the NYU SPS Center for Global Affairs, or CGA. I'd like to welcome you to the May Energy Data Meetup. This meetup is presented by the NYU SPS Energy, Climate Justice, and Sustainability Lab and the NYU SPS Center for Global Affairs. Our aim is to provide a virtual space to connect students, industry professionals, and those interested in advancing energy analytics to facilitate discussions and collaboration between non-technical and technical professionals. We've been offering these presentations monthly for the last several months, and we welcome anyone here who is interested in volunteering as a presenter for future months to go ahead and reach out to me, and I'll be sure to include all of that information in a follow-up email. So before we go any further, I'd like to now just kick this over to Joe Silver. We're really excited about tonight's event. It's a little different than some of our past energy meetups, but it's very special. And so, Joe, I'll go ahead and kick it over to you.
Thank you so much, Michelle. So yeah, thank you all for joining tonight at the Capstone presentations for the Certificate in Clean Energy. My name is Joe Silver, and I'm an adjunct faculty at the NYU School of Professional Studies for the certificate program. My day job, I work at Con Edison on the non-pipeline solutions team, focused on strategies to decarbonize our gas business primarily by supporting customers' heating electrification goals. So for tonight, and for many of these students, it's the culmination of a year-long certificate program where they've been learning about the clean tech and energy industry, primarily the technologies, market, and policies that are supporting this energy transition here in New York and around the world. The program is designed to support mid-career professionals looking to transition into the clean tech sector. So none have come from an energy or clean tech background, and the work tonight that they're showcasing, they've really only been working on specifically since February. And so you'll see it's very impressive what they've done in a short period of time. I want to thank Brian, Linda, James, Will, Sabrina, and G for all their hard and impressive work they've done this semester. And I also want to thank Michelle again from the NYU School of Professional Studies for managing the whole certificate program. So tonight, you're going to hear from two separate teams, one that researched energy storage opportunities and the other that investigated heat pumps. Both were hosted kindly by Urban Energy, a local New York solar startup and project developer. In a minute, I'm going to introduce Russell Wilcox, the founder and CEO of that company, to share a bit more about his experience hosting these students and what Urban Energy does. But first, just quick logistics. Each team is going to have 15 minutes to present on their topics, and then we'll open it up for Q&A for about 10 minutes. Please feel free to submit questions in the Zoom chat while they're going, and then we'll have a little moderated Q&A. We can turn mics off, or we can read from the questions in the chat. But feel free to raise your hand if you'd like to ask your question directly. I'm going to be strict on the teams and cut each of them off at the 15-minute mark. So you'll also hear me chime in when they've got 3 minutes left approximately to give them some warning. And that's pretty much it. So thanks again for joining. And I'd like to turn it over to Russell to share a bit more about Urban Energy and his experience as a Capstone host.
Yeah, thanks, Joe. And thanks for having me. I'm Russell Wilcox, the founder and CEO of Urban Energy. We're a solar developer at EPC based in Williamsburg, Brooklyn. We've been affiliated with NYU for as long as I can remember being in New York City. I think probably met Joe in 2016, and he really helped sort of kick off my New York City clean energy journey. So it's kind of feels like a culmination of a lot of the work that him and I have done. And then we were in the Urban Future Lab the last few years as well. So that's another great NYU partnership. So yeah, I've had a great experience working with the two teams. We're starting to look at some energy storage paired with our solar systems on large multifamily and commercial buildings in New York City. And, we're seeing a large trend for larger energy storage deployments to help with grid services and other sort of Con Edison initiatives that they're having out there. And then, definitely a huge proponent of full electrification on all buildings, but specifically urban multifamily buildings have kind of not had the sort of focus that they've needed. So I think it was really interesting to work with the teams on looking at different solutions and, the different ideas that, we have to kind of make these buildings as electrified as possible. And, I bring sort of engineering as my background, but with our solar development, we do a lot of financial modeling and larger scale project finance. So I think it's nice to look at projects on a sort of return of capital and feasibility standpoint. And so, we put a lot of focus on the technology, but also the actual financials and return on investment, that a institutional investor would be interested in. So yeah, thanks again for letting me participate, and I look forward to hearing about the presentations. And I think there's a lot of excitement about future deployments with the New York State's clean energy goals. So yeah, thanks, Joe.
Awesome. Thank you so much for hosting this semester. I can say all the students had a great time learning and working with you. So with that, we'll turn it over to the energy storage team, which is going to go first. I'll let them take over and share the screen, and I will be timing.
Hi, everyone. Welcome to the energy storage team's presentation. This is a presentation on bigger isn't always better. As Joe mentioned earlier, our sponsor was by Urban Energy based in Brooklyn, New York. And before we get started, I'll go through what we'll discuss this evening. So we'll go through a brief introduction of our team, Urban Energy, and the problem we're trying to solve. Then we'll go through our methodology. Part 3 will be our financial analysis. And then we'll conclude with our next steps and hopefully a little bit of discussion. So tonight I am joined with my team members, James Clark and Brian Hellman. We all come from different professional backgrounds, but we all have a passion and interest in clean energy. And so that's why we are here today. Leveraged and really sponsored by Urban Energy and Russell Wilcox, who is the CEO. Urban Energy is a Brooklyn-based renewable energy company offering solutions in innovative small and commercial family buildings, as it was just mentioned. They are a target market and have great area portfolio for storage. And so we'd love to talk to you a little bit more on the opportunity that is presented with BESS. So battery energy storage systems, or BESS, like I just mentioned, have a crucial link in the renewable markets that are coming up crucially and critically. Not only does it reduce the cost on consumers, especially in lower to middle income communities, it provides an economic opportunity, especially that is place-based, especially for storage systems. Not only paired with this opportunity, New York State and New York City have created ambitious climate impact goals that create a platform for storage energy systems to thrive. And then lastly, it reduces the grid, it reduces stress on the grid and provides ancillary services when there is peak metering. So I wanted to touch a little bit more on the energy goals, because this is really the platform in which New York set up. And so the Climate Leadership Community Protection Act, the CLCPA, set very ambitious environmental and carbon reduction goals by 2030. New York City also followed suit with these goals. And so just to give you a little bit of better understanding or a little bit more color with this, by 3,000 megawatts by 2030, that is looking like 100 to 300 storage sites. And then with New York City, it's looking like 10 to 30 storage sites by 2025. What's really important to note here is that we're setting up the environment for front of the line or front of the meter bill crediting, but we're just still at 2% of the goal. What really is happening also is NYSERDA and NYISO also set up a system of incentives and have changed the regulations so that small to mid-sized developers can work together and also compete in the integration of standalone energy systems. So developers are responding to this, which is really good. So we just have to prepare the grid and the environment to support these goals. And so right now in the queue, we are at 10,482 megawatts of storage, which is almost 3.5 times of the amount of the goal and what it can support in New York State. And then almost 6 times the amount of goal in New York City. So really what we want to explore is trying to make the interconnection process plug and play. So that way we can support more smaller developers coming in and out of the grid. On top of this is the value stack. And so in this transition in 2022 for solar and storage, there's been 6 key types of bill crediting. I'm not going to read through all 6, you can see them here, but it definitely helps with smaller developers getting into the market. And so that leads me into the transition into our part 2. BESS is an attractive opportunity for storage developers. There's an expected return on investment of 14%. We'll touch a little bit more of that on our financial analysis. There's 2.5 times the return of capital, the tax benefits, and then there's bill reductions for owners and energy users. There's improved reliability of the grid and lower costs of the grid maintenance for Con Ed and other energy providers. Honestly, the BESS also helps reduce grid stress. It provides cheaper electricity. It's stronger renewable energy, and then it also helps improve our grid resilience. And so with that, I'm going to pass it on to James to talk a little bit more.
Thank you, Sabrina. Thanks for the introduction. So I'll discuss today what our team did when looking for potential sites to install BESS, as well as what energy storage systems you would actually go with. And it really, as you'll see in this section, it really does we owe a lot of credit to the state of New York and Con Edison for providing all of these resources for free, such as where we start is with the Con Edison hosting capacity web application. A lot of information here, but essentially you can see it's a free map on their website where they provide you essentially where you can. They provide you the context of where you can actually install a battery energy storage system. So you get a lot of other useful data that you can filter through. It's a very dynamic and data-rich application. You can find out what kind of capacities can support your energy storage system. You can also get load curve data, so you understand what that what that desired area, what kind of power they're actually using at what time of the day. You can also get a gauge on where you can earn more credit and bring in more revenue because of your additional services that you provide, such as the very famous locational system release value credit, which is essentially if you are providing more relief from the stress of the grid during peak hours, you will be eligible for this credit, but only in specific neighborhoods. So you can identify those neighborhoods through this actual application. Going from that, we also considered environmental justice areas by going to the New York City Mayor's Office portal, which provides a very useful map about where we can provide a larger impact with our BESS, presumably or particularly a larger social impact on lower income neighborhoods. We also used just general kind of like private company sites like Zillow and Remax to understand what properties were available. But actually in going about looking for those, we had to consider that we could only put a BESS in ground level and outdoors. It had to be of a certain square footage. We prefer around 1,000 square foot to allow a buffer around, what would be the BESS and an inverter. And then of course, we're kind of just really at the end, we're striking a balance between the square footage price and really the size of the area. So that was an interesting test to approach. We also considered another New York City resource, which is the zoning and land use map, also known as the ZOLA map. This helps us understand any development restrictions or what permits we might need. And we did learn that there are very heavy restrictions that kind of go against BESS development. We do think that there will be some changes that support it more in the future, but if we were to install one, say tomorrow, we kind of get a clear understanding. All of this information that I presented so far will really come in handy when we submit our final application. But before I get to that, we'll discuss a little bit about the batteries and kind of the criteria, what we consider when, and what the city considers really about what battery energy storage systems qualify. So we reached out to a bunch of manufacturers. As you can see, we got a useful quote from Tesla, which is the most, obviously, I think everyone here would say is the most popular company. But there were other really compelling energy storage solutions from Infinity and Simplify, as well as Fluence. Just to do a quick comparison of the two, or of all four, and we'll narrow it down. Running through the criteria, what really had the most importance was if it was approved by the fire department. But when we look into it a little bit more closely between those two companies that are approved by the fire department, which is Tesla and this company here, which is Simplify, they have their trade-offs. So Tesla is a lower price, but actually a little bit of a higher risk. Simplify, on the other hand, is a lower risk, but a higher cost upfront. We would expect other battery companies to be vetted by the fire department, but again, this is a very new market, and that means that the technology is constantly improving. So as it improves, it has to be re-vetted by the fire department, which was kind of another interesting roadblock that we considered. Just going about the size of the battery, thanks to Brian and his financial analysis, he found through the value stack or through the value of DER calculator that actually the smaller batteries that we would install yielded higher profit. And that really came from the charging cost that Con Edison would charge, as you charge the battery. So you can see this battery modeled on the left here in this graph. This had a lower cost to charge. As that goes higher, you can see that relative percentage increase as the battery capacity increases.
James, about 3 minutes left. Okay,
and I'll pass it off to Brian in just a second. You get all this, compile all of this information, and you have to submit it in a very, in 3 different entities, the DOB, the FDNY, and Con Edison, and it's not a very straightforward process. We should also say that a lot of people are in the queue, as we said earlier, and actually the total amount of folks or projects that are in the renewable interconnection queue, it actually adds up to more than the total capacity of all fuels currently connected today. So that's an interesting point before I pass it off to Brian. Thanks.
Thanks, James. And as we talk about the financial analysis, as James mentioned, NYSERDA and New York Sun have developed a very powerful data tool for developers to help contractors provide a better estimate of compensation for projects. And so that's the VEDR calculator. The great element of this is it's using 3 years of wholesale pricing data and developing a model for you to maximize charge discharge and to maximize your overall return. Next slide, James. So, and just to give you a sense here, this is from January on the left in the morning, all the way through December in the evening on the right. And what you'll see here is a pretty heavy use of the battery in January winter months. So it's charging in the wee hours and then discharging at peak for heating after 6 o'clock in the winter. And then here in the summertime in the middle, you get quite a bit of activity. Next slide, James. Here's just the projected charge discharge cycle. And you can see again, early in the year, pretty heavy use, not as much in the middle of the year. Next slide, James. And this is just looking at the capacity payments. What you see here is on the ICap payments, you do get paid. This is based on the one hour a year of peak use. But where that flows through ultimately is in August. So gives you a little bit of your energy output and your ICap payments. Next slide, James. So overall expected internal rate of return of 14%. We built in a 1% fee for Urban Energy as a manager, about 13% net. Positive cash flow from year one. The electricity deployment happens primarily between June and September. Most revenue in a single day, 158,000. Significant tax benefits to investors. We did model a 6% preferred interest to help finance the battery purchase. That's the biggest, about $3 million plus maintenance going forward. Next slide, James. This is just looking at pro forma expected revenue over the course of the life of the battery. This case actually that Tesla would provide 25 years of expected lifetime, and that's where we modeled. We modeled it over, but we did take the locational system relief disappears after 10 years. We put it in the Fordham circuit to try to get that. We did identify a place we think is attractive to site a battery, and I'm about to put my $5,000 down on a battery reservation. Demand reduction value, inflation rate. We did include a little inflation in the DRV payments, and also expenses go up, particularly for maintenance of the battery over time. Next slide, James.
And then Brian, I'm going to have to cut you off there.
And I think in terms of conclusions, we've identified the site. We're ready to go ahead and implement that with our partners in New York. Looking forward to seeing more energy storage sited in the future. Thank you.
Awesome. Great work, team. Thank you for all the hard work on that presentation and all the work you've done the last few months. Really fantastic. With that, I will turn it over to the heat pump team to take control again.
Cool. Look good?
Looks great.
All right.
Time starts now.
Sweet. All right. So hi, everyone. Thanks for taking the time to join and listen to our presentation today. So this is our final capstone presentation as been outlined for certificate in clean energy through NYU. And so as mentioned before, we're the clean heat team. So just a quick intro. My name is Will Whipple, and I completed this research along with Linda Tatlow and Jiwon Choi, who you'll hear from later in this presentation. And so why clean heat? So mentioned this at the top, but we scoped this out in collaboration with our industry host, Urban Energy, and our NYU advisors, because it's an adjacent industry with Urban Energy's business, solar installation. And before we dive in further, we'd just like to thank Urban Energy and Russell for their assistance in advisory throughout this project, as well as our NYU Capstone professor, Joe. And so first, a little background on New York City's building energy usage problem. So if there's one number I want you to remember today when it comes to clean heat in New York City, it's that 23.4% of all of New York City's greenhouse gas emissions in 2020 came from residential fossil fuel space and hot water heating. And so how do we change that, right? So one of the primary ways we can do so is through policy. And while there are a few different policies out there through the Climate Mobilization Act at the local level, the main policy that we focused on in our analysis is Local Law 97, which sets carbon emissions limits for buildings in 2024 and 2030. And that's going to affect about 75% of New York City's building stock by 2030. And so to meet those Local Law 97 targets, there's a series of building energy efficiency tools at our disposal, right? So things as basic as LED lights, upgrades, building insulation, and window replacement, obviously getting more complicated as you go up that scale. But today we'll be focusing on heat pumps. So we'll get into the benefits a little bit further, but at a very high level, heat pumps replace oil and natural gas boilers, and you'll use electricity to both heat and cool the home. And just to focus our scope a little bit more, we focused on pre-war multifamily homes, since this makes up much of Urban Energy's existing building portfolio. And so heat pumps have been around a while, and we've seen them pretty commonly used in the American Southwest and much of Europe and Asia. The market penetration in this region has been primarily limited to single or smaller multifamily homes and new construction. So multifamily home retrofits are still definitely pretty new. And so for those retrofits, right, so we're focused primarily on systematic heat pumps, where there's contracting work involved as far as installation of the heat pumps themselves, electrical wiring and refrigeration lines. And so I'll skip over the technical details of exactly how they work for now. But what's important, I think, is that what's shown here is a mini split system. So that just means there's a corresponding outdoor unit and an indoor unit. And for retrofits, these mini splits or also multi-splits, where there's basically one outdoor unit for multiple indoor units, this is the most practical system for a multifamily home retrofit. And so I mentioned that heat pump retrofits are still being adopted in the US for these type of buildings. And so we wanted to spend some time talking about why that is. At the highest level, I think one of the reasons that heat pumps, are slow to get adopted is they weren't really viable for this region in the past, just because of the temperature that they could go down to. But with modern heat pumps, they can go down to as cool as, negative 13 degrees Fahrenheit or colder. So it goes beyond that, though. So I'll walk through some of the challenges that exist today, as well as some opportunities coming down the line. So first, from a social perspective, right, change can be scary. A lack of proof points, with these retrofits being done leads to hesitancy from building owners, contractors, and investors. But it's important that we try more of these, right? So heat pumps provide adequate and just as importantly controlled heating and cooling, so you don't experience like those crazy imbalances that we have in a lot of radiator buildings today. And it's not only important just from a comfort perspective, but also health, right? So if you just have inadequate heat in the winter, and especially with climate change and hotter summers, air conditioning is becoming more of a necessity rather than just something for comfort. From a technical perspective, the global supply chain issues have affected heat pumps as well. And there's also been increased demand. So there's equipment availability issues, as well as a shortage of contractors with the level of knowledge necessary to install them today. But again, this is an area of opportunity. So according to a 2019 industry report in clean energy in New York State, there are about 159,000 jobs in clean energy, about 80% of those in energy efficiency. So that number is growing. It's expected to grow more. And there are programs in place from NYISO and certain manufacturers in terms of training. From an economic perspective, heat pumps are pretty expensive up front. And until Russia invaded Ukraine recently, natural gas had been very cheap, especially compared to electricity rates in the New York City area. So switching from, burning, gas to electricity makes the value prop there a little bit tough. But there's state level incentive programs. And then, if federal legislation ever passes, that'll help with the equation as well. Environmentally, one of probably the biggest long-term risk of heat pumps is refrigerant leaks. That can have a huge greenhouse gas effect. But I touched on this, but the big benefit for heat pumps is, right, you switch it from a fossil fuel source to an electric heating. And while our grid is largely powered by natural gas today, by 2030, that should be about 70% renewable. And then also the equipment itself. So heat pumps are just more efficient than fossil fuel sources. So they literally use less energy for the same output. And then finally, politically, it takes the right policy mix and coordination among a few agencies to get this right. So that's a challenge, but obviously, if we get that right, that's a huge benefit as well. So I'll pass it over to G to talk about how this looks in action today a little bit more.
Thanks, Will. So from challenges to action, where are we currently in heat pump retrofits in multifamily buildings? And what's actually being done to address the challenges at local level, right? So it turns out in terms of medium to large multifamily, we're mostly in planning stages, but the small number of demonstration projects do highlight many aspects of the work that needs to be tackled. In this section, we'll look at a few key elements that are driving forward the action for clean heat, starting from leadership. So first, we have a 10-unit co-op in Upper West Side, which converted its heating from oil. And we highlight two of the key learnings. One is leadership and having medium to long-term vision, where immediate payback may not be high in dollar terms, but it still produces significant greenhouse gas reductions. plus changing conditions of conditions of fuel prices and grid power mix could change things drastically. And two, another is the importance of contractor and technician training to increase the quality of work, decrease shortage of labor, which move in lockstep with policy push. So the work involves refrigerants, as we just mentioned, so this is very important. And on the right, going larger scale, we have a collaboration between New York City State Energy and Research Development Authority. It is a direct injection to provide gap funding to bridge the gap between typical system upgrades, such as boiler update that people are familiar with, and accessing the funds for clean heat and other measures in HPD housing to build proof points of heat pump retrofits in pre-war regulated multifamily homes. So all about simplifying the process. Next, please. So now we pan out further to large-scale deployment. In 2020, NYCHA, New York City Housing Authority, experimented with retrofitting 7 apartments on a top floor with heat pumps, which took them 10 days per apartment and is described as disruptive to residents and generally an administrative nightmare. So they asked whether they could use large-scale buying power to lure manufacturers into developing a new product. So the question led to the Clean Heat for All Challenge, a competition for a new product supported by the partnership of NYSERDA, NYPA, and NYCHA, which has promised $263 million to purchase and install 24,000 units, the winning model, and along with window replacement and other repairs. So the RFP asks for a unit costing less than $3,000 that operates at 0 degrees or lower. And that also can be installed in less than 2 hours as opposed to 10 days. And there are already a few companies making products that are close to qualifying, and having these options to build momentum is really important since policymakers can't move without options. So there are also other pilot projects and experimental projects, such as electrifying Ithaca, which we can share later, of course. Next slide, please. So technology and cost, what about the cost side of the equation, right? So most of you are familiar with the solar PV learning rate, and it's nearly 100% cost reduction since 1976. So since widespread heat pump installation is just in the beginning to be discussed in New York, we see opportunities in technological development that will reduce the modular cost of heat pumps while increasing efficiency. As well, engineering and installation costs could also decrease over time as more heat pumps are installed and the skills become mainstream. So decrease in human errors from training will also help with reduced O&M costs. And lastly, yes, as Will mentioned, heat pump prices are on the rise at the moment for various reasons, but solar, as you can see from 2003 to 8, you can also see it also had polysilicon price issues, but eventually stuck to the learning curve. So from cost reduction opportunity to economics and finance of heat pumps, Linda will discuss our financial model.
Thank you so much, G, and good evening, everyone. So I'm going to walk you through how we looked at the financial feasibility of retrofitting a medium-sized multifamily building. And our first step was basically to identify the best candidates for heat pumps. And for that, we used research prepared by Urban Green. You can see on this table, they outlined 3 characteristics that make for the best heat pump candidates or retrofit candidates, and they are owner occupancy, buildings heated with expensive fuels, as well as those with a hard to upgrade one pipe system. As you can imagine, the pool of buildings that meet all 3 criteria is fairly small, but luckily we identified 2 buildings within Urban Green's portfolio that met 2 of the 3 criteria. Next slide, please. So I'm going to walk you through one of the 2, which is the building on the left, a 47-unit affordable housing building. It's oil heated and has a one pipe steam system. There's also no submetering. So we projected the financials, assuming conversion of heating to heat pumps and the continued use of the boiler for domestic hot water with an associated increase in usage. We also modeled operating cost savings based on continuation of heating at current levels. 2 additional revenue streams that we identified were the tax benefits associated with depreciation, as well as lower local law 97 fines. So the results were a 15% operating savings, 45% reduction in energy and CO2, and then an IRR just below 4%, which on its face is not super attractive for landlords. But next slide, please. The good news is that there are many financial levers that can be pulled to improve the financial outlook for heat pump retrofits, and I'll walk through them outlined on this slide. So
3 minutes, Linda, just a heads up. You're doing great though.
Thanks. So the first one is lower rates. So we've seen this at PSE&G. They offered lower rates during the winter, taking advantage of excess capacity on their grid. Then the second one is lower project costs. As we kind of alluded to a couple of times, we expect these to come down as more contractors develop expertise in installation. And then higher incentives, and this could be either at the state or federal level. As we mentioned, there's no federal tax credits right now, and those have been very instrumental in propelling solar across the country. Then the next one is a cleaner grid, which kind of translates into lower local law 97 fines when a heat pump is installed. And then the last two are really, they impact only rental buildings, and those include accelerated depreciation, which again, we saw on the solar side, and it's provided a significant financial incentive for deployment, and as well as changes to the sub-metering laws. Next slide, please. So we wanted to basically look at how all these levers might change the financial picture. We prepared a scenario analysis that incorporated changes based on our research, and then the feedback we heard from the market participants we spoke to on how they saw the market evolving. And you can see that there are many different, as I went through, there's definitely different levers that can be pulled, and there might be more than one at a time. But the big picture takeaway is that the lever that moved the picture the most is the installation costs. So we modeled a 20% reduction in those costs, and the result was an IRR above 7%. And we feel that this is very reasonable based on conversations that we had with manufacturers and contractors, as well as what we've seen with our industry hosts and how they've developed an expertise in installation of solar canopies, and that's resulted in a real competitive advantage. So next slide, please. So I'm just going to finish with a couple of conclusions and recommendations. High level, like our team sees that heat pumps are going to be an essential part of the decarbonization efforts in New York City. We think that the market's evolving rapidly, and changes in any financial levers will accelerate adoption. So it's a market to watch closely and watch for more proof points. We also, as we alluded to a few times, think that training contractors really represents an opportunity to differentiate and to capture market share in the market. Another place where we see opportunity is the combination of solar and heat pumps together. We think that the ROI on a combined project might look fairly attractive to landlords. And then finally, we would recommend a couple areas for researching further. One of them being owner-occupied buildings with electric resistance heating, or buildings with boilers that are kind of at the brink, ready to be replaced. And then kind of taking a look at the broader equipment landscape, as our analysis focused mainly on one manufacturer. And with that, I'd like to thank everyone for coming and open it up to questions.
Great work, everybody. Thank you so much for all the great questions and for joining the whole time. This was recorded, so we'll be able to share that out as well. And yeah, I just want to again thank the students for doing such a good job in the last few months. And if you're interested in the Clean Start program, the certificate in clean energy, or anything else happening at NYU or the Urban Future Lab, feel free to reach out to the organizers. And I want to also thank Russell one last time for hosting these teams this year. And I guess that's everything. Thanks again.